It's 3:30 now. Should I mean, probably I will just wait for another like 5 minutes. Okay, before we start. Just wait for another 5 minutes to get everyone in. It's like 3:35 now, so I guess I'll just start off the talk right now. Okay, so hi everyone, and welcome to today's session. This will be a recorded session where you can find the recorded version on YouTube. Thank you for joining us today. Today's talk on different engineering field. My name is Nicole, and I'm the MC for today. Now, I would like to introduce my committee members for this talk. Kelly, please.
Hello everyone, I'm the OC for this event.
Hi everyone, I'm Alicia and I'm the event secretary.
Hi everyone, I'm Sukin and later I'll be in charge of the Kahoot quiz and I'm the vice OC of this event.
Okay, thank you. So your active participation is really important throughout the session. Right now, can I have everyone on mute to avoid background noises that may distract you from listening to the talk? You can enter your questions or comments in the chat box throughout the presentation. So we'll have a Q&A session at the end to answer all your doubts. On behalf of the Institution of Engineers Malaysia, Swinburne Sarawak Student Section, I thank everyone for joining us here today. I would like to thank St. Joseph Private School for giving us this opportunity to organize this talk. We hope every student find this information and dialogue valuable in gaining a more in-depth understanding of various engineering fields' main focuses. And I would like to also thank and welcome our speakers for today. Welcome Dr. Angela, Dr. Victor, Dr. Hadi, Dr. Chiu, and Dr. Lai. We are really honored to have you all here with us today to share your insights on different engineering fields. So now let us get straight into the content. We are privileged to have our first guest speaker today, Dr. Angela, for telling us what civil engineering is about. Dr. Angela, please.
Thank you, Nicole. Thank you. Hello, everyone. Can you all hear me?
Yes.
Yeah. Good.
Yeah. Okay, so I'll share my file because I have a presentation slide here. Give me a moment.
Okay. Yeah, you can share your screen, Dr. Angela.
Yeah, I'm sharing it now. Wait,
Okay.
That's my file. Can you all see this file?
Yes, all good.
All right. Probably I'll just off my camera so that the line is better this way. Wait, Okay. All right. On full screen. Okay, a very good afternoon, everyone. I'm Dr. Angela Liew. I hope everyone can hear me and I hope everyone is keeping safe and well. And thank you for joining in. Today, we will be conducting a series of talks related to a career as an engineer in different engineering disciplines. So I will start with a brief introduction about myself. I'm a senior lecturer at Swinburne University of Technology, Sarawak campus, a civil engineer by profession. Briefly, I have 17 years of experience. I graduated in 2004 with the Bachelor of Engineering Honours in Civil Engineering. Upon graduation, I worked as a civil engineer at the design office and spent a fair bit of time at the construction site as a site engineer. So after working for about 4 years, I continued my postgraduate studies. So in 2012, I was awarded the Doctor of Philosophy in Civil Engineering from the National University of Singapore. I stayed in Singapore for about 3 years, working as a researcher and a project manager with the university. So, and finally, in 2015, I've decided to come back to my beloved hometown, Kuching. And currently, I'm lecturing at Swinburne Sarawak. At the same time, I'm also a civil engineering consultant, as well as the independent consultant for my alma mater, National University of Singapore. And that's briefly about myself. If you have any question, you can type in the chat box. I will address the question later. Okay. Okay. So let's go to the topic of the day. So engineering is concerned with the implementation of solutions to practical problems. So a scientist may ask, just an example, they may ask why, and they will proceed to research the answers to find the answer of the questions. On the other hand, the engineers, they will actually want to know how to solve the problems, and they want to find the answer for that problems. They will get a solution. So that's why everyone says that the engineers are the problem solver. All right. I hope you feel the same. So let us look at the 4 major branches in engineering. So there are civil, chemical, electrical, and mechanical engineering. And of course, there are many other areas of specializations, such as what my colleague Dr. Lai would be presenting later, which is on robotic and mechatronic engineering. And well, whichever discipline, engineering is all about solving problems and possess an analytical mind. Okay. So I'll be covering topics on civil engineering and a career as a civil engineer. All right, so what is civil engineering? If I'm too soft or I'm not loud enough, let me know, Nicole. So civil engineering is everything you see that has been built around us. Of course, it has a very, very long and impressive history, from 4,500-year-old of the Egyptian pyramid to 2,300 years old of the Great Wall of China. And till now, the world's tallest building that we have today, civil engineering is the way to go. All right. So the civil engineering encompasses a variety of sub-discipline and jobs. You can become, if you take up civil engineering program, you can become a structural engineer, environmental, water resources engineer, geotechnical, construction, and transportation engineer. All right. So civil engineering focuses on design, construction, maintenance, and the operation of a project. The project can be a multi-story building. It can be a bridge project, a tunnel, a water system project, road traffic system, or a foundation supports, and many more. All right. So let's look at the engineering marvels around us. So civil engineering is actually one of the oldest type of engineering. So if you look at around us, so much of the physical infrastructure that make out of our modern society is made possible by civil engineers. So as you can see here, the dam, the world's largest dam, Three Gorges Dam. So this is made possible by civil engineers. Hong Kong-Zhuhai Macau Bridge, which is the longest sea bridge, and Kansai International Airport. I'm just giving a few examples. So world first offshore airport that built on a completely man-made island. And of course, not forgotten our Petronas Twin Tower, the Malaysian National's pride, which is the tallest building in the world from 1998 to 2004, before it was surpassed by the Taipei 101. Okay, so as a civil engineer, we involved in the construction and maintenance of all these public works. Okay, like I mentioned earlier, such as bridge, roads, railway, pipeline, airports, hospital, and school. All right. So in my earlier slide, probably I have discussed about the difference between a scientist and an engineer. So probably some of you may be asking, what's the difference between a civil engineering and an architecture program? So I'll just give you some example here, where an architecture program deals with the look and other artistic aspect of designing a building. As if you take up civil engineering program, you are mainly deal with the maths and the scientific aspect of that building. So architecture will deal more on the aesthetics of the structure, whereas civil engineering will deal more with the strength of the structures. So as an architect, they design, they plan the floor plan of the building and design the shape of the building as well as the exterior of the building. So as a civil engineer, we deal with the material that we're going to use for the building and how to design the building so it can support on its own weight. All right. So I guess probably all my colleagues here, the engineers or probably the civil engineer will agree with me on this, which is an architect's dreams is a civil engineer's nightmare. They can have many different kind of concept, but it's us, the civil engineer or the engineer, will have to fulfill whatever they are designed. Okay, so in other words, the architects essentially do, or what they essentially do is to control and innovate the overall aesthetic of a building or a structure, where civil engineer will need to design and construct to align with their ideas. All right. Okay, let's go to the sub-disciplines of civil engineering. Like I mentioned earlier, under civil engineering, we do have different sub-specialties. So there are, I will just describe a few here, which is structural engineering. There are geotechnical engineering, water resources engineering, and transportation engineering. Of course, not forgetting the construction, environmental, coastal engineering, etc. These are all part under the subdiscipline of civil engineering. All right, so I'll go through the four main subdisciplines in civil engineering. So for structural engineering, we are dealing with mostly calculation, and we understand the forces, strength, and stability of a structure, be it a bridge structure or a building. So it's very math intensive, and it actually involves a lot of physics. So the structural engineer actually analyze and design a structure that will safely bear the estimated load that we design. Okay. As for the geotechnical engineering, it is the study of the behavior of the earth material in terms of the rock and soil. So they also study the ground improvement technique. So a geotechnical engineer, they're involved in designing of foundation, slope, retaining structures, tunnel, reclamation, and also deep excavations. All right. For water resources engineering, I'm a hydrologist. So I'm actually belong to these water resources engineering subdisciplines. So what we do is we design a system to manage human water resources, be it a water treatment, dams, channels, canals, and pipelines. So the water resources engineer that develop techniques to prevent floods, they plan and manage the facilities like the mega canals for irrigation, seawall for drainage to avoid waterlogging, and also all the works that related to the usage and the control of water. Okay, so we also meet water requirements of the society and also the environments, such as the water resources engineer will build water treatment plants and the pipe networks to convey the water from the treatment plants to the tap that you're using at home. And also we design the wastewater, the sewer from the toilet of your house to the treatment unit. Okay, so these are basically the scope of the water resources engineers. All right, so the last one that I would like to describe on is the transportation engineering. So a transport engineer plan, design, build, operate, and maintain a system of transport in such a way that it provides a very safe, efficient, and convenient movement to the people and goods. All right, so such as an example here, there are highway, airport, railway, public transportation. All these are part under transportation engineering. Okay, a transport engineer will study on the new development. For example, if you were to build a new township, so the transport engineer will come in and they will study the impact of this development to the existing traffic, and they will provide an improvement or solution to the existing transportation, like adding a new lane to the road or providing a bus stop, or sometimes they will upgrade that particular road section, etc. So these are the role of a transportation engineer. Okay. All right. If you have questions related to the subdiscipline, please type your questions on the chat box. So probably you'll be asking yourself, all right, how do I become a civil engineer? So I'll just briefly go through it so that you roughly get the idea what should you do or what are the roadmap that you can plan in order to become an engineer or a civil engineer. All right. So firstly, in school, I believe most of you now are probably in your secondary form 4 or form 5. So you have to focus on maths and science subject. Okay. A little bit of computer skills and design and technology knowledge would be very helpful. So civil engineers, we usually deals with a very large team of group members. So because they are all coming from different backgrounds, they do design, planning, etc. So if you like group work or team sport in your school, this will really help in building your attribute as an engineer. All right. So let's look at this. If you're now in your SPM, so currently if you're taking your SPM or in your form 4, so this probably will be the first route. So if you were to decided to take up engineering program, so you can either take up a foundation study 1 year, or you can, some of you may want to continue with your STPM form 6, or you want to do your A-level, you are okay to do so. So you will be in route 2. So once you completed this, you will have to enroll to an accredited bachelor degree program in civil engineering and complete your 4 years of engineering training degree programs in a university. So upon graduation, Of course, you have to work to get experience. So you will be called an engineer in training. So if you were to apply or you want to become a professional engineer, or in this case, because my topic is on civil engineer. So if you want to become a professional civil engineer, so you have to gain enough experience, at least 3 to 4 years of experience to pass the exam and interview. So to become a professional civil engineer. So in case some of you feel that, whatever I know now, the knowledge that I know now is insufficient, and you want to master in some of the subspecialties, specialties in civil engineering, you can go for a master degree to focus on one particular specialties. So for example, like if you want to become a structural engineer, a structure specialist, so you can enroll to a master degree that focus on the structures, expertise. Or if you want to advance even more, you should go for a doctorate degree. All right. So this is basically a route on how you can become a civil engineer. Okay. So here goes the duties of a civil engineer. So becoming an engineer, these are some, just giving you some idea what you're going to do once you graduated. Because for the benefits of some of our students here, our students from student chapter, probably now you're in your 3rd or 4th year, you will be imagining how or what are the duties of a civil engineer. So as a civil engineer, you provide technical advice to industry regarding to your design, the construction progress or program modification, etc. Okay, as a civil engineer also, you have to consider construction costs. You have to know government's regulations and also to study the potential environmental impacts. Okay, let's say if you were to construct a building at that particular area, you also have to understand what are the environmental impacts that is going to be one of the factor in your planning. All right. So as a civil engineer, you have to oversee and analyze the result of soil testing, because you need to design foundation. So you have to determine the adequacy and strength of the foundation. Other than the result from the soil testing, you also have to, I would say you also have to analyze the test on the building material. Building material in this case means the concrete. You have to know the grade of the concrete. You have to know the asphalt grade, the steel that you use to build the factory, etc. So you have to know all this to know testing results for all these building materials. And as a civil engineer, you need to estimate quantities and cost of materials, equipment, and also labor to determine the feasibility of the project. Okay, and being a civil engineer also, we have to manage, if you happen to be given a responsibility to manage a site, so you have to manage and direct the construction progress, including the operational and the maintenance activity at the project site. All right. So last but not least, you will, as an engineer, you will have to present findings to the public or to your client as the bid proposal, or in terms of environmental impact statement, or even to promote your projects. Okay. So communication skill is very important as an engineer. All right. So here comes a more interesting slide, because probably some of you would like to know what are the career opportunities as a civil engineer. So if you see here, I actually quoted I extracted this from the Straits Times in 2018. It says here, Malaysia needs about 500,000 of scientists and engineers by 2020 to meet the challenges of the 4th Industrial Revolution, or we call that IR 4.0. Okay, and in 2018, they say to date there were only 100,000 registered engineers in the country. So I managed to get some statistics from last year's reports. So it says that in February 2020, the Board of Engineers Malaysia registered graduate engineers and professional engineers stands about 137,000. I believe now in 2021 we should have about 140 plus thousands of registered engineers. Okay, and civil engineers take about 50,000 among this the figures. All right, so to become a developed nation, I put a ratio here. So this is the standard ratio for a developed nation. The engineer to population ratio should be about one engineer serving 100 people or 100 populations. So for Malaysia, we have about 32 millions of populations, and the number of engineers that we should have is about 300,000. So we are very far behind the numbers. Therefore, the conclusion from these statements is to tell you that the engineering career is still in a very high demand. All right. So here are the career opportunities. You can, after you graduated from your civil engineering program, you can become a consultant, working in a consulting firm and as a design engineer. And you can work as a project manager, coordinator. You work in the building and construction industry. You work like the sub-discipline in the transportation, water resources, etc. You can be a hydrologist. You can be a project management consultant or construction consultant, or you can go into research and development, and also you can become academics. All right. So then the previous slide is on the career opportunities. So here we look at the what are the salaries for fresh graduates, or to be more specific, in engineering field. So I highlighted here. I didn't manage to get the 2020 salaries guideline, but 2019 should be quite near to it. So I managed to highlight here this building construction, which is related to our civil engineering, or I would say engineering industry, and also the salary for the engineering industry. So it's about 2005 to 2008. Okay, that is a very, very good pay as a fresh graduates. Okay, so based on the job street Malaysia, so you can expect a salary between 2000 to 2008 for a fresh graduate. All right. Okay, so of course, the previous slides I mentioned about working as a consultant or contractors, but what I want to tell you from this slide is that studying civil is not just about working as a design or site engineer. So you can also venture into entrepreneurships. So if you can see here, the Business Insider in their article mentioned that 20% of the Fortune 500 CEOs have a degree in engineering. Not only civil engineering, but overall as a general engineering degree. Therefore, engineering can be a very, very good education background for a career in business, either as a, if you want to become an entrepreneur or you want to become a professional executive. So these are the example of successful entrepreneur outside and within Malaysia, who is also a trained civil engineer. So give an example here, founder of Huawei, Ren Zhengfei, Carlos Slim, Mexico's wealthiest man and one of the richest self-made billionaires in the world. So he's also a trained civil engineer. The famous Kwok brothers, Walter and Thomas Kwok, they are the owner of Song Hung Kai property, which is one of, probably Hong Kong's largest real estate developer. To bring it nearer to us, they are also the co-developer of the Iron Orchard in Singapore. So both brothers are actually trained civil engineer. Okay, so nearer to our in Malaysia, so there are successful entrepreneur in Malaysia who is also a trained civil engineer. As you can see here, the managing director of YTL Group Companies, Tan Sri Dr. Francis Yeo, he's a trained civil engineer. The group managing director of Gamuda Berhad, Datuk Lim Yun Lin, he's also a trained civil engineer. Or you can see here the notable civil engineer in Malaysia, which is our Minister of Transport. He's also the president of MCA, which is Datuk Sri IR Dr. Wee Ka Siong. He's actually, his PhD is in transportation. All right. So these are some of the example of becoming the career options or opportunity of a civil engineer. All right. So probably some of you may be asking, is civil engineering profession still possible in the post-COVID-19 era? So basically what I show here, because I know that everyone is very uncertain, don't know which program to take up, whether civil engineering profession is still on high demand in the post-COVID era, COVID-19 era. So I show here, this slide here shows the construction side of the future, which I will call it a digitalization in construction industry. So basically, engineers is still needed, but there will be the sensor installed at the site. There will be automations, robots. All these will be automated, and management of the site will be you go online. So these are something that we are looking forward in the future. So to answer your questions, will engineer have jobs in the post-19 world? Of course, short-term impact of COVID-19 on engineering jobs is yes, is there, but it will be temporary. And I would say yes, engineers will be still be in high demand in a post-COVID-19 world. And to prepare yourself for post-COVID-19 world, these are some of the skill sets, okay, that will be in demand. Okay. So because of COVID-19, we are actually fully embraced into the digital world. So we are actually, we have to optimize the remote working where possible using a digital software in our working practices. So for engineering design, we will be leading towards IR 4.0 with 3D simulation tools. So you have to understand a little bit about the software on how to create a 3D models. I'm giving an example here on building information modeling, which presented an ideal stage for development, etc. So the hard copy of the drawings and document will soon be replaced by the use of digital copies. Okay, and digital transformation is new norm in architecture field, engineering, and construction industry. All right, I think that's all from my talk. If you have questions, you can do it later on. I believe we have a Q&A session, and I shall pass back the floor to you, Nicole.
All right. Thank you, Dr. Angelia.
Thank you.
So to get some of his insight into what mechanical engineering is about, let us welcome Dr. Victor. Dr. Victor, please.
All right, thanks, Nicole. Can everyone hear me?
Yes, good.
All right, I will need to share my screen. Okay, can you guys see?
Yeah, we can.
Oops. Let me get back to the... All right, good afternoon, everyone. So I will try to make this very straightforward for everyone. So my name is Victor, and I'm going to present on a short introduction to mechanical engineering. And just a little bit on myself, I'm currently a mechanical engineering lecturer in Swinburne University. And prior to this, I was actually working as a project engineer, not only overseeing mechanical engineering projects, but more towards engineering management in general. So that was before I went back to the university to continue with my PhD studies. And right after I've graduated with my PhD, I have been teaching mechanical engineering and also doing research related to BEAM and also HVAC. Okay, so that's a little bit about me. So I think previously Dr. Angelia has already explained to everyone who are engineers. So I'll just go through briefly again. So engineers are basically problem solvers. We basically like problems. We basically see problems in the world and we develop solutions for the problems. Okay, so this is an example, classic example of tower crane before. Okay, because you want to build mega structures, you want to build tall buildings, and somehow you need cranes to solve your problem. So engineers come up with solutions to that. And another example of problems is that we look at birds, we see that birds can fly. And as humans, we have a dream to fly as well. So the Wright brothers, I think most of you are familiar with this. Two brothers, they came up with this airplane invention. So basically, these are problems in real life, and engineers, when we see the problems, we solve the problems. So engineers are basically problem solvers. Now, just a little bit on of addition to these problem solvers. If you look at this little comic strip here, it's a different perspective, showing you a different perspective from mechanical engineering point of view, chemical engineering point of view, electrical engineering point of view, and also from the software engineering point of view. When you have a problem, okay, for this example, it's actually a problem with the car. So depending on which engineering field or which engineering discipline you are in, you tend to look at problems differently from a different aspect or different angle. For example, mechanical engineer, since we deal with the engines, we deal with engine pistons, we would think that if the car is not moving, it's the problem with the engine. Okay, for chemical engineers, since they deal with fuel, they deal with gas, petrol. So when the problem arises, when they are sitting in the car, they may think about the fuel system. Okay, maybe your fuel doesn't reach your engine. So maybe your fuel is dirty. So it's from another angle. Then when we look at electrical engineers, they would think that it's electrical problem. It could be a grounding problem that leads to the car not working. If it's the software engineer, then they would think from the programming point of view. So probably it's because there's a glitch with the program. Once you unplug everything, you reboot the system, then everything works again. It's like your computer, right? So then let's put this into perspective. Nowadays, engineers are basically still problem solvers, but they are also creative and collaborative problem solvers. They need to be creative when they find out what is the root cause of the problem, and they also need to work with different people with different knowledge, okay, to solve problems. So now let's come back to this again. Who are mechanical engineers? This is the main presentation. So what exactly are mechanical engineers? What is mechanical engineering, and what do mechanical engineers do? So if you look at this comic strip, it gives you a rough idea, right? What is the first idea that you have as a mechanical engineer? Probably people will think about cars. Okay, mechanical engineers, basically we design cars, we build cars, we build machines. Not only cars, maybe some of you will think about building ships, building airplanes, building spacecrafts, building space stations, or, well, I hope no one thinks about UFOs. So some of the common perceptions that people has about mechanical engineering: space shuttle, as I mentioned earlier, airplanes, ships, and some of you may think about oil and gas platforms. Yes, there are a lot of different mechanical services on board. Some of you may think about cars, about F1s. That's correct too. And very seldom, but there are people who knows that air conditioning, the aircon that you use in your homes or in your offices or in any commercial buildings, this is also related to mechanical engineering. So there are a lot of things that is related to mechanical engineering. So mechanical engineering engineers basically research, design, develop, build, and test mechanical and thermal devices. And this includes any kind of tools, engines, and also machines. Okay, anything dealing with things that moves, basically mechanical engineering will be involved. And anything which deals with fluid flow or any kind of thermal devices that involves heat transfer, mechanical engineers are also involved. So mechanical engineers in general, we analyze problems to see how mechanical and thermal devices can help to solve the problem. So if we look at mechanical engineering discipline, this actually applies to engineering physics, mathematics, and material science principles to design, to analyze, manufacture, and also maintain any kind of mechanical systems. And also it is one of the oldest and broadest of the engineering disciplines. So if you want to look at the sub-disciplines, you can think about manufacturing fields, okay, thermal field, automotive, which deal with cars, or let's say is the electric vehicles. It can be acoustical field, aerospace, naval, biomedical, and also structural. Okay, these are just some of the common disciplines. So just in short, as I mentioned earlier, mechanical engineers basically mechanize the world, make things moving. So you can be designing engines. Okay, you can be designing any kind of mechanical systems like gears. Okay, if you have watched Transformers before, all the moving parts, those are actually mechanical system design. And it can be any kind of manufacturing tools or manufacturing technologies. It can also be combustion engines, jet engines, or it can be as simple as the watch mechanism. If anyone of you has some automatic or mechanical watch, you will realize how many gears and moving parts are in your watch. So these are actually mechanical system design as well. So it can be as big as something like space shuttle to something as small as the mechanism in your watch. Okay, these are all related to mechanical engineering. So if we look at some of the mechanical engineering marvels, so as I mentioned, it can be something really small, like the first picture you see on the top left is a nano engine. Basically, it's actually an engine that works on a single atom, or it can be something big, such as the aircraft carrier, okay, or the giant vehicle of land, the Bagel 288, which is used for mining. Okay, so you can always think about something as small on the nanoscale, on the atomic level, which is related to mechanical engineering, or it can be huge structures that you are building, which can also be related back to mechanical engineering. So there are basically several areas of interest. Let's say if you really decide to go into mechanical engineering in the future, these are basically some of the areas of interest that you can venture. So I will just briefly go through with you each one of them. So the first area is biomedical and engineering fluid mechanics. Okay, some of you may think that I don't like biology, or that's why you want to take physics instead, or chemistry instead. And some of you may actually like physics and biology at the same time, and even chemistry, and you can't decide which area you want to go to. Well, one idea for you is, how about looking into biomedical or bioengineering field? Okay, this is actually a subdiscipline for mechanical engineering as well. So basically, you are going to design things like artificial hearts or prosthetics, limbs, like mechanical arms, for example. This requires you to apply fundamentals in mechanical engineering, especially in fluid mechanics and also machine design, right? For you to get these sort of things to work. So other example is for blood circulation in the body, okay? Or outside, you may be looking at different types of flows, okay? Different types of flows can be related to aerodynamics, such as if you are designing a plane or a car or a ship, you need to look at what is the best way to design it to reduce resistance so that your vehicle will be more fuel efficient and it can move faster, right? So these are some examples. Now, another field that you may be interested in is combustion and the environment. So these days we talk about more efficient or cleaner engines, for example, to reduce the pollution around the world. So mechanical engineering are also involved in this case, either in the design of internal combustion engines, such as your car engines, or anything to generate electricity or power, like gas turbines or furnaces. Okay, so to do this, you need to understand the aspects of thermodynamics and also combustion, right? Now, another possible field that you may go into is ground vehicle systems. Okay, you may be involved in design of electric vehicles, for example, or you may be involved in research of alternatively fueled power systems, like electric drives for electric vehicles. Another field would be heat transfer or thermodynamics and energy systems. So this can be related to your aircon system. The picture on the left is actually the centralized air conditioning systems that you often see in big buildings, such as your shopping malls. These are actually using big centralized air conditioning systems. Or you may be dealing with power plants, okay, using different combustion cycles for energy generation. So mechanical engineers are involved in this as well. And in addition to that, you may also be involved in the manufacturing industry. So this involves the design of the process for manufacturing or design of the machines used for manufacturing. of course, nowadays we talk about Internet of Things, we talk about IR 4.0, and a lot has to be integrated with automation system as well, which I believe you may need to get into robotics and mechatronics field to be more involved in this kind of automation design. Another area of interest is, of course, the one of the original mechanical engineering area, which is mechanical design. So you'll be designing machines, you'll be designing gears or mechanisms that makes things work, that drive any kind of machines. All right. But of course, with the more and more emphasis on being environmental friendly, mechanical engineers will need to look into sustainability and how to make use of environmental friendly materials and how to come up with environmental friendly design. Okay. And another field is system dynamics and controls. Again, this has to do with, for example, your building controls. Nowadays, we talk about smart homes, we talk about smart buildings, we talk about smart HVAC or smart centralized air conditioning system, or just energy management system to manage the energy consumption of your building. So mechanical engineers do get involved in these fields because of our knowledge with all the building services involved. Now, another area of interest is transportation systems. If any one of you is interested in railways, okay, or in any kind of integrated transportation systems, mechanical engineering could be also one of the stepping stones for you, because it requires you to have many of the fundamentals, okay, in mechanical engineering in order to come up with the design or implementation of these systems. So just in general, mechanical engineering is a very broad field, as you can see. Whatever that you learn, whatever that you study can be applied into more specific fields. So that depends on what fields you want to specialize later. So in career-wise, you can be involved in engineering, transport, manufacturing, construction, or process companies. You may also end up doing research and development, consultancies, or you may be working with utilities companies. For example, in Kuching, we have Sarawak Energy or SESCO for electricity. We have Kuching Water Board for water supply. Okay, you may be working with these companies. You may be also joining the government in civil service, or you may be joining military for design of military equipment or vehicles. All right. You may also be involved as a sales engineer. So there is endless possibilities when it comes to careers in engineering, mechanical engineering to be more specific. So it depends on which area you would like to specialize in. Now, an example roles of a mechanical engineer. Well, you can end up doing design, okay, whichever role or whichever career path that you want to follow. As I get, as in the examples which I've provided you, you may end up doing design. You may end up doing production, especially if you are going into the manufacturing field. You may end up also doing maintenance. For example, if you are in the automotive field or if you are in the building services field, depending on your scope of work, you may end up be doing maintenance. You may end up doing sales as well, or any other kinds of role like checking quality or occupational health and safety, or even doing financial forecasting. You may also end up in planning. Okay, so this will require you to have project management skills and to understand how, in the bigger picture, how things work out. Or, of course, as Dr. Angelia mentioned earlier, you can also end up doing your own business, starting your own business and be an entrepreneur. All right. And one very stark contrast between engineering graduate and business graduate is that it's easier for engineering graduates in general to get into business rather than the other way around. All right. And that is also because of the kind of grind and the kind of training that you get throughout your studies. All right. So if we come back to this, let's say if you want to do engineering, then what is most important for you? you need to start from the fundamentals. Fundamentals means that your physics and mathematics, especially for mechanical engineering, your physics and mathematics has to be strong. Okay, you need to develop in these two subjects. Otherwise, once you start your engineering education later in your degree, you would go into different fields which are more specific. So that includes material and manufacturing science, thermodynamics and heat transfer, fluid mechanics, machine dynamics, control systems, static analysis, engineering management, and again, depending on which field you are going to join, you are going to choose different kinds of subjects again to top up that goes on top of all this. So next question is, do you think you have what it takes to be an engineer? So these are some of the important skills which we have identified over the years based on our experience that you should learn and develop along the way in order for you to be a successful engineer. So you need to have good technical skills, which usually you learn over your degree studies. And after that, you keep on perfecting them as you work. And on top of that, you need to have the ability to work under pressure. You need to have good problem-solving skills, the type of creativity, interpersonal skills, as Dr. Angela mentioned before. So you need to always work in a team. You need to have good communication skills, commercial awareness. Okay, it's all about dollars and cents these days. Even if you are engineers, you can't run away from budgeting. And lastly, also team working skills. So another important question that you should answer is, do you have the passion or interest in engineering? Okay, before deciding to take this as a career path, make sure you think this through carefully. Now, another word of advice is that engineering is getting increasingly multidisciplinary these days. So you don't work alone. No one is working in the silo. Everyone is collaborating these days. So there are many crossovers to be expected in the future, and you will be definitely working in cross-disciplinary teams in the real world. So it is something that you need to learn to communicate with different people. Okay, if you remember the comic strip from earlier, okay, even in the car itself, you can have so many different fields or areas involved. You can have mechanical, chemical, electrical, even software these days when it comes to automation, right? So remember, no one works alone now. You need to practice your teamwork. Some of the notable people who are related to mechanical engineering, you have people who design the engines like Niklaus Otto or Rudolf Diesel, people related to the air conditioning systems like Willis Carrier. You would remember him if you use the air conditioning which is branded Carrier. He is the one who actually started it. And we have Nikola Tesla. And when we think about cars, it's always Henry Ford, one of the first names that come to mind. On railways is George Stephenson, and James Watt deals with your steamships engines, right? So this is my final slide. So I would like to wish every one of you all the best in thinking or planning your career. And one word of advice, it's not only for mechanical engineering, it's going to be whatever field you are in, is that tomorrow's engineers cannot solve tomorrow's problem with yesterday's thinking, all right? Problems that matter are always constantly evolving, so we need to be creative and we need to constantly improve ourselves, all right? This applies not only in engineering, but in every other fields that you may want to go into in the future. All right, I think that's all from me. Thank you, everyone. I'll pass it back to you, Nicole.
All right, thank you, Dr. Victor, for your advices. Thank you. So I'm pleased to invite Dr. Hadi to tell us what electrical and electronic engineering is about.
Yeah,
Dr.
hello.
Hadi, please. Yes,
Hello,
hi.
everyone.
Hi.
I hope everyone fine. So everyone, let me share first my screen. And I guess I think I stopped my camera because maybe my net going to be not so good. So you can see my screen, right?
Yes, yes, we can.
Okay. So hi, very good afternoon, everyone. So hope everyone fine and safe these days. Today we are going to talk about electronic and electrical engineering for me, actually. So thank you, Dr. Angelia and Dr. Victor, that you give significant information about engineering. So I'm not going to talk about engineering, general information of that. I'm just going to straightforward to electrical and electronic engineering. So before I start, I just give some short introduction of myself. So I'm Hadi Nabipour as a discipline leader and senior lecturer in electrical and electronic program in Swinburne University of Technology. So I received my bachelor of degree in electronic engineering from Iran in 2005. Then after that, I completed my master of engineering from University Technology of Malaysia, UTM, in 2011. And after that, I received my PhD from the same university in 2015. And followed by, I finished 1 year of postdoctoral research at University of Tehran, Iran. And then in 2017, I joined Swinburne as a lecturer, now senior lecturer at the Faculty of Engineering, Computing and Science. Until now, I'm here, I'm working here, and I'm so happy to work here. Okay, so as I said, I just concentrate and focus on electrical engineering. So we are going to review what is EE, what EE does, and who we are collaborating with, and what we are going to learn in electrical engineering, and what are the careers after we graduate. So you can see the two different pictures here, which is electrical and electronic. I'm sure it's confusing for many of you. I will explain actually what's the differences between these two. But before that, I can say that electrical engineering is at the heart of everything we do. So as electrical engineers, they are inventors and innovators who apply knowledge of signals, circuit, physics, mathematics, and signals and systems to develop technologies to improve people's life. We as an engineer, all the type of engineers, we are going to improve people's life. And electrical engineer, we have a special place here, position here, because any devices around ourselves, we can see without electrical engineer, it's impossible to be here. Like now, we are conducting this session without our PC, our laptop, our internet. It's impossible to conduct this online session these days because of this pandemic. We cannot go face to face. Our phone, our smart home these days, we heard, our transportation like our car, and any motherboard, electrical board that we use in any electrical device, any electrical appliance that we have at home, or television, air condition. Now we are sitting in the room enjoying the nice, it's around 25 temperature, 23 temperature. You can make it as cooler as you like, because electrical engineering give you this opportunity. So let's explain about a bit about the differences between electrical and electronic. So electrical power engineering mostly cover the generation, transmission, and distribution. Usually they talk about high voltage, high current, and power. And the most concern there is about electricity, how we generate electricity, which sources we use to generate electricity. After generation, how we transmit them, and then how distribute them. Beside, we have electronic. Electronic also cover telecommunication, control system, signal processing, system engineering. Mostly, usually, they talk about low voltage, low current, and power, and they concern about development and application of electric device and circuit. Most of the device that we have, the sensors, is about electronics. So I hope we get an idea of what's the differences between these two. So the big scale, we talk about electrical, and in a smaller scale, we can say is in electronic. So what do EE engineers do? So of course we do anything, but I'm going to shortlist some of them, some of the important things. The most important thing that EE does is we providing electricity for entire city, state, country, whole planet. And these days, life without electricity is almost impossible. So we need to find out the sources, could be traditional sources or renewable sources like wind, hydropower, solar system to generate electricity and transmit to the location that we need. Of course, we need to collaborate with mechanical, civil to implement this system, to provide the system. As Dr. Victor mentioned, these days we cannot work alone. We have to collaborate with other programs. So this is our main contribution, to generate electricity. Develop the technologies which allow people to communicate with each other and access information from wherever and whenever. How many hours per day you spend your time with your phone? Many apps these days we're sending, texting each other, we're watching video. All of them is possible because EE make it possible for us. So we use internet now to conduct this session. In the high skill, in the high tech, I'm pretty sure that everyone heard these days about Mars exploration rover that NASA sent to the latest one NASA sent to the Mars to explore and give us information about what's happening in the Mars now. So how we can communicate with that? Of course, the rover going to do some exploration there, doing some tests there. So this data should be transferred to the Earth, to us. So this is the complicated way to communicate. So it's not just our phone that we just send joke and then funny video to each other. This is a serious communication way. Also, we can conduct a video call to our family to hear on that. These are all the communication that EE engineers involve there and make it possible. Develop the technologies for affordable, clean, efficient energy, such as solar power generation. I guess all of you every day you can see the solar panel day by day increasing everywhere. And you heard a lot about that. So collaboration with material science, chemical engineer, we are going to produce the new type of this solar cell to increase the efficiency, to generate more energy, and then we shift from the traditional fossil fuel to renewable energy to reduce our CO2 emission, to save our planet, to be nice to our environment. Other than this, EE engineers develop new technologies that make sensors smaller, better, more accurate, and more reliable and energy efficient. In the last 10 years, you can imagine how our phone developed, from which size to which size. What we are holding now is so nice, so holdable. But compared to last 10 years, so our laptop, in 1975, you can see the type of laptop, how big it was. Even you couldn't carry it here and there. But these days we use notebook. All this possible because EE engineers try to develop this technology. Electrical board, all our computer, our servers need the electrical board. Using the micrometer size of these devices, even smaller or bigger. In one of this figure, you can see the control panel of the airplane, and the space station. The space station is one of the high-tech and complicated technology that EE engineer is most involved there. So we have to prepare and develop this technology to prepare this small electrical board and more accurate sensor. Medical care, we need to develop the technology to improve medical care. Most of the equipment that when you go to hospital, I hope no one of us go to hospital, but anyway, of course, we need these devices to care about ourselves for the medical care. It's built by electrical engineers. Of course, with collaboration with mechanical engineer, with medical engineers, bioengineering. So machine like X-ray, like CT scan. So these are developed by EE engineers. Transportation. So EE engineering, planning, design, construction, maintenance, and operation of transportation facilities. These facilities covered the air, highway, railroad, even a space transportation. These days we have planned to send human to moon, to Earth, to the Mars. So we heard a lot about electric vehicle. Of course, you know the reason that why we need to move to electric vehicle because of reducing the CO2 emission. Also, the subway, electrical bus, electrical train, and these all have been done by collaboration with mechanical engineering and other engineering. Okay, to do all these things, what we need to learn in EE program, in Bachelor of BE Engineering. So we need to learn the mathematical physics. So all the engineering actually, either civil or mechanical or electrical or robotic, we should be good in mathematics and physics. This is fundamental. So we will learn about programming, calculus, linear algebra, physics, chemistry. Some of the tools that we learn in EE engineering is circuit and electronic, electromagnetics, signals, systems, semiconductor, digital system, and also design engineering and technical communication. To learn all these tools, we need to pass some courses. So I just list down some of the courses that we pass in Swinburne to learn and to fulfill all the gaps that we said that we need to learn communication, to design electric car, to generate electricity, to design an electrical board, to know how this programming works, how this computer works. So we need to pass some related topic or related unit. I categorize them, some of them here. You can see under the math and physics, we need to pass linear algebra and application. They are the name of the unit that we offer, energy and motion. Under the electronic, we have circuit and system, analog electronic, embedded microcontroller. Under the electrical, which is about generation, transmission, and distribution, we have electrical power system, mechanical machine, power electronic, and under the communication, we have communication principle. Other than this, we need to learn research. 4 years that we learn, we are going to graduate as a Bachelor of Electrical Engineer. We need to do the research in the electrical field. So we offer 2 units, which is final year research project and integrated design project. Okay, what are the EE careers? I guess it's one of the important questions for everyone in this level that, okay, what I will be later after I graduate. I can say that we have a wide range of opportunity after our graduation because almost all the industry, factory, industry, they need electrical engineers. So we can become electrical engineer, electronic engineer, designer, software engineer. You can be the astronaut. You can be biomedical engineer, hardware designer, computer engineer. Also, even we can work as a technical sales engineer and project manager. So there's no limitation that what you're going to be, but based on your interest at the last year, you just increase and add some other field that you are interested to. And why? Why we need to be an electrical engineer? We are going to change the world, and we are doing that. We already changed the world. Just read the history last 50 years. The most changes in technology has done by EEL engineers. Of course, with collaboration with other engineering. It's not possible without the collaboration. But we are at the forefront of practical technology. Just as I mentioned at the beginning of my presentation about Mars exploration rover, it is the recent, the high technology that these days in the world we have. So we send the rover to the Mars. Of course, we collaborate with robotic engineers, mechanical, and we send this one. And now this rover in the Mars far from our planet, explore the get the soil, do some tests, and then send us the information. So all those sensors should be created by us, by electrical engineers. How we are going to generate electricity for that rover in the Earth, in the Mars, which is far from us. How we are going to control it. All this technology, we have to think about that as electrical engineers. So that's what I said. We work at the forefront of practical technology. We need to design, innovate, and improving the service and system we use every day, all the appliances around ourselves, from solar energy to mobile phone. Of course, as an engineer, any field of engineer, we need to be creative, solve problems. We need to be designer, like design, how to design it. And as electrical engineer, we never be bored. And we can make reasonable salary. This is Dr. Angelia explained about the salary of as a graduate, engineer graduate. So I'm not going to explain about that, but the salary is reasonable. The range is already given by Dr. Angelia. I guess I stop here, and that's all for me. I hope I could give some information about electrical engineers to you. If you have any question later, maybe you can ask, and it's my pleasure to answer.
All right. Thank you, Dr. Hadi.
You're welcome. Just I need to mention that I need to leave because I have class.
Ah, okay. All right.
Thank you all.
Thank you.
Bye for now.
Okay, bye. Thank you, Dr. Hadi.
Hadi.
Thank you. Bye.
Thank you.
So everyone, join me in welcoming Dr. Chiu to show us what chemical engineering is about.
Hello, good
Hi.
afternoon. Just call me by my name, JJ. I'm not really using that doctorate title. So good afternoon. I was just joking with the committee behind the scene that I'll be done in 5 minutes. So my colleague basically did a very good job explaining engineering to everybody. So Victor had talked about teamwork, Hadi talked about collaboration of various engineering, and Angela basically shared all about, how much you're getting paid, what's the demand for engineers. So yeah, I'm down to a few slides only, right? So just give me a minute. I'm gonna off the video to ensure that the whole talk goes smoothly, all right? So give me a minute. Okay, where is my slide? All right, can you all see my slides?
Yes.
Okay, great.
Okay.
So good afternoon. My name is JJ. I'm a chemical engineer, so I was told that I need to introduce myself a little bit more. So here we go. Yes, okay, so that's me. So I'm a chartered professional engineer with Engineers Australia. I am also the discipline leader for chemical engineering program here in Swinburne, Sarawak. So that means that if you come here, join us for chemical engineering, you see me a lot, okay? So I got my degree in 2006, Bachelor of Engineering with honors in chemical engineering. Oh, don't count the age. So then after graduation, I practiced for about 3 years as a process engineer. So that's where I learned to shout at people. No, I learned quite a bit of human skills from there. It was a very nice experience. So after 3 years, then I've decided, okay, it's time for me to move on. Then I've decided to actually start my PhD in chemical engineering in Monash, Malaysia. They gave me scholarships, so yeah, just go and join them. So anyway, so then I joined Swinburne Sarawak in 2014 actually. So I completed my thesis while I was still working. So that's roughly me. So students normally just call me JJ. So but other than all this, I'm also a mother of 2 very naughty children and a mother of another 100+ students here in Swinburne Sarawak. Okay, so that's about me. Now, I did have a pretty comprehensive slide across my heart, but well, everybody covered everything. So while I was listening, I was like, okay, removing slides. So there we are. We're down to 3. So first thing first, I'm going to cover what is chemical engineering and who are these people, because it seems like my identity is a bit hard to define at times as a chemical engineer, and what's fun about doing chemical engineering. Okay, so that's what I'm going to cover. Okay, oops. Okay, now first thing first. Okay, I am not a chemist. I like to clarify. I'm an engineer. So what's the difference between a chemist and a chemical engineer is the only thing similar is CHEMI. That's it. Okay, so chemical engineers are more into application, while my counterparts on the science stream who will major in chemistry, they are more into fundamentals. And as a chemical engineer who holds a PhD and is interested in chemistry and research and application, so I'm in somewhere in the middle whereby I will try to balance between fundamental study and application. So that's basically what chemical engineering is about. So what a lot of people think is that when you do a chemical engineering degree, you're going to be studying chemistry all the time. But don't forget, the first word is chemical, the second word is actually engineering. Okay, so I will talk about this a bit more as we go along. So how do I define where and what the chemical engineers actually touch and do, and basically where are we fitted in the whole scenario that everybody is talking about engineering? Okay, now I took a picture of the desk. So it's very messy. And on my desk, there are things like, there's my teacups, there's my takeout containers, there's jumbles of sticky notes, there's files, there's my laptop, there's printers, there's phone. So I blame the chemical engineers for the mess on my desk. Yeah, I know. So why do I blame them? Because they make life so convenient and so easy. Basically, chemical engineers are involved in every single step that made all this possible and land it on your table. So there is such a varied career path for chemical engineers. Sometimes our identity gets clouded. Nobody knows exactly where they are. But in reality, is chemical engineers influence every single of this item that's on my desk. So taking the word of Eliana Levine, who's the president of Quantum Success Solution, she points them as chemical engineers are people who are trained to see the pain points, that have the ability to figure out what's the barrier, and then they create innovation solutions to overcome them. So pretty much similar to what my colleagues has actually said earlier. We are problem solvers. We don't look at problems, we look for solution. Okay. Now, chemical engineering. Okay. Now, where exactly is this area focused on? So it's a discipline that basically influences numerous areas of technology. Without us, things cannot go from lab scales to mass production. We are that key element there. In a broader term, chemical engineers basically conceive and design processes. That's why from the example of Victor, when there's a problem with the car, the first thing we'll think about is, oh man, the one that's fueling this, there must have a problem with the fuel, or there's a problem with the process of getting the fuel out to drive the car. So we design processes to produce, to transform, and transport materials, beginning with experimentation in the laboratory, which most of the time our scientific partners, our scientist friends actually do most of this experimentation. But we are also involved because when you do experiment, it can be very nice. It can be a 99 to 100% efficiency. But to make it out into the market at a reasonable price, at something that people can afford, then there is always a tug of war between efficiency and also producibility. So then we are the one that will actually help to implement the technology into full-scale production. Let's say amidst the COVID-19 situation right now, in order for vaccines to be produced in mass quantity at a price that's affordable and having been able to be transported across half the globe, there are going to be a lot of chemical engineers working behind the scene to actually make the vaccine go from the lab until large-scale production and reaching each and every one of us at a very cost-effective price. So that's what chemical engineers do. We change materials into useful product, be it the clothes you wear, the food you eat, the energy they're using, what's fueling your car, or the waste that is coming out from your home and everything else. We are concerned a lot about managing resources. We are also involved in protecting the environment and also the health and safety of the community. So basically, that's what we do. The main problem why it's so hard to define us is because we touch everything. You can't say exactly where we practice. There's no defined role for it. And that's the beauty of this whole profession, actually. Now, so I like to call us the universal engineer. So why universal engineer is because it's a very broad discipline. We basically concerned with transforming one thing into another. Basically, we touch everything. I also like to call us the practical chemist. It's very hard for people to actually divorce chemistry from our area of practice, and it's not possible as well, because for us, it's a program that is actually our area of practice is a marriage between chemistry, physics, and maths. And most of the time, it's about life science and physical science. And there's also we also have a lot of emphasis on economics, because for us, things need to be optimized. It means that there needs to be a balance between cost and production. And there's always maths and there's always physics. And of course, adding on, there's a teamwork, there's a communication, and definitely you have to be somebody who has a curious mind. Okay, so these are some of the very crucial things that you might want to look for, whether you have it or not, then perhaps this may be an area of interest to you. Okay, now I was sitting there and pondering, how shall I continue our presentation now that everyone has mentioned everything? So I decided, okay, let's talk about one of the most common things that people will ask me when I talk about chemical engineering. So first thing first, what do I study for chemical engineering as a degree? Okay. Most people are not very sure about the amount of chemistry involved in chemical engineering degree. Roughly, it's about 30%, while the remaining 70% encompasses about maths and physics in different manner. And then there are also some elements which are of chemical engineering which are related to biology, but this will be typically for more specialized area, like if you're interested in biological processes, Or if you like to specialize, so end of the day, what I'm trying to say is that if you are interested to specialize in pure chemistry, lab coats, lab work every single day, then you may perhaps want to consider a degree that is on the science side. Okay, so chemical engineering is not pure chemistry. It is about application. Okay, so that is what we will cover a lot. It's not like I'm going to be teaching maths for like, 1 whole year, physics for 1 whole year. We don't introduce it in that manner. It's a lot more fun the way that we do it. So let's not bore you with that. Next one. So is chemical engineering hard? Okay, if I tell you it's easy peasy, cross my heart, I'm lying. Okay, so it's undeniably challenging because of the broad spectrum of careers that will await you. There is a price to pay for it. It will involve a lot of physics, a lot of maths, and a lot of connection of making chemistry actually work behind the scene with physics and maths. It's actually unimaginable for most secondary students because these are very unique units and subjects in your school. And it will also involve a lot of practical application. We look a lot into real world application. But although all this said, it is very varied and very interesting. So if you're comfortable with scientific requirements, committed to persevering and genuinely interested in subjects that you like, this degree is not going to be too hard. It's going to be very, very much grounded. Next one, is chemical engineering a good degree? Okay, so let's come to this. Among the general public, there's not a lot of understanding of what chemical engineers actually do because it's a relatively new discipline compared to the other engineering disciplines that have been explained. However, most employers do respect the strong elements of science and maths and recognize that this is a challenging degree. And despite having relatively unknown subject in the general field, it is recognized as a degree that can develop a lot of useful skills. So now, 5 fun facts about chemical engineering is people recognize that we are well employed into oil and gas and they pay us very well. And it is among one of the highest paying because of the specializations of the process that we can handle. It allows you to move around a lot because of the broad spectrum that you can handle. And there are very interestingly more females in our area of practice as compared to others because our area of practice allows us to choose whether we want to practice on the field, we want to practice in the office, or we want to practice behind the scene behind the computer screen. So there's a lot of opportunities in different areas. And if you choose to be, you can be a game changer when you have a chemical engineering degree. I'll explain a little bit why. Now, chemical engineers, there's a research done by the Institute of Chemical Engineers in UK that on average, a chemical engineer can have up to 3 change of career path along their lifespan. Now, 3 change of career path means like me, I went from a process engineer to become an academician. So that's a change already. So you can have 3 change, and for an adult, if you go back and ask a lot of your parents or your uncles, 3 change of career path is not easy. But for chemical engineers, it's not uncommon because of the area that we practice and the skills that we have. Changing career is not an issue. It may seem unimportant now, but as you grow and mature further with more commitments, this is actually something that is very much valuable. It gives you that flexibility. Okay, so is it a good degree? I would say that you will acquire lots of variety of skills. You'll be highly employable. There's a lot of exciting career choices for you to choose from. You get to choose what you want to practice on. And it's not very restrictive. And you have the opportunity to change the role if you want to. So is it good? Yep, I would say it's good. Now, can I change to a different kind of engineering? Or okay. One thing that a lot of people are curious is whether chemical engineers can become a different kind of engineers or not. Example, can I become a nuclear engineer? Can I become a petroleum or environmental engineer? It is definitely possible because chemical engineering develops a very broad range of skills. However, many engineering disciplines actually require a higher degree of specialization. So although chemical engineering is a good basis or foundation to start, you'll probably need to do a postgraduate study to change to another discipline. Like I have a friend, she was into occupational safety health. And what happened is she took a master's and she became a specialist in OSH area. So it is possible for you to change to a different kind of engineering. I think this is the last question. So what kind of job can I get? Oh, this is important. You need to know what you're going to get after 4 years doing a degree with us. So there's a wide range of industries that utilize chemical engineers like pharmaceutical, energy, IT, just to name a few common ones. So this role will involve developing existing process, creating new methods for altering materials, and there are also other sectors and careers which utilize the skills that you develop during your degree. Example, quality assurance, manufacturing, consultancies. So there are plenty of excellent opportunities for chemical engineering graduates, and there's prospect for higher earnings in the profession. Their work in certain industries, example like oil and contracting, will definitely attract particularly attractive salaries. So these are some common examples for this region of the world, which we are quite common. You can be in oil and gas or energy, petrochemical. You can be in water industry. You can be in environmental. You can be in specialty chemicals. We have a lot of oleochemicals in Malaysia. You can be food and consumer productions. You can be in engineering consultancies and manufacturing, and definitely electronics. I used to practice there too. I do not know anything about circuit board, but I'm very good at making plating, those kind of electrolysis process, which allows the product to actually come out as designed by the engineers. So now, what is it in store for the next generation? People will be like, oh, engineering, that's like an age-old profession. My grandfather used to practice that. What does it hold for me? Now, the thing is, as long as there's a problem, it equates to an opportunity for the next generation. In my area, we will look at, people will always need energy. There's always a need for equity, and there's always a need for ecology. So these are the areas that will be what the new generation will look at. Now, chemical industries, then a lot of people, oh my God, people these days need to be more sustainable. I'm not going to use chemicals. It's evil. It's bad for the environment. Let's be realistic. People hate plastic. Can you go without your underwear? The answer is no. So for the next generation, it's not about condemning what has been done, but rather, can you look at ways to actually balance and replace, reduce, and reuse all of this? Whatever process that has been developed, can you make it greener? Can you make it a lot more environmental friendly? Can you make it carbon free? So there's actually a lot of opportunities for the young generation to make things much better than what has been done in the past. So for me, I would say that it's an area that is expanding and expanding fast, because with the demand of people growing more and more, there's actually a lot of rooms for problems to be resolved, and that will equate to opportunities. Now, what can I do beyond chemical engineering? What if I don't want to practice in the areas that you have said? Well, these are some examples. You can become a president if you want. The president of China, Xi Jinping, he holds a degree in chemical engineering. Or you can become CEO of an oil and gas company like Madame Grassa here. Or if you don't like all of that, you can go into environmental protection agency like Lisa, or like Arthur, become the inventor of post-it notes. So there's a lot of things you can actually do with the skills that you have from chemical engineering. So if you're thinking of a career without the box, I would say that this will be a good career area that you can look at. There is tons of opportunity for you to actually venture into. So if anyone wants to actually find out more, and you're a bit shy to ask during the Q&A, you're always free to actually write to me. My email address is here. It's jchu@swinburne.edu.my. I'll be more than happy to share my passion in this profession with you. So with that, I finished my presentation. Thank you to SJPS for actually inviting us, and IEM Swinburne Sarawak Student Chapter for actually organizing this. So Nicole, back to you.
Okay, thank you, JJ, for this insightful presentation. So I would now like to welcome our last guest speaker, Dr. Lai, to share what robotics and mechatronic engineering is about.
Hello. Can you hear me?
Hi. Yes.
All right.
Loud and clear.
Good. Okay, can you see my screen?
Yes. Good.
All right. So before I start, just let me introduce myself. My name is Lai Chean Hung. You can call me Lai. And I obtained my Bachelor of Engineering in Robotics and Mechatronics in Swinburne. I was one of the graduates from the first batch. All right. And then right after I graduated, I worked as an engineer in a manufacturing plant. And then in 2008, I took my PhD program. And then I got my PhD in 2012. All right, so I start the academic career. I start lecturing since 2010. Okay, so I have about 10 years of experience in teaching into robotics and mechatronics courses. All right, so So before I start, just want to introduce to you what is a mechatronics and what is a robotics. Okay, so robotics, you probably have already some ideas what's robotics, but mechatronics, maybe you know, maybe you do not know. All right, so mechatronic is a very new engineering field. Right, just now JJ said chemical is new, but this one is newer, right? Newer. So the term mechatronics actually originated from a Japanese company in 1971. And by that time, mechatronics basically described an engineering field that integrates the mechanical engineering, electronics engineering, plus some of the computer software. All right, but so by combining all these things to make the systems to be automated. All right, to automate the process. So mechatronics is basically an interdisciplinary branch of engineering that encompasses electrical and electronic engineering, mechanical engineering and product designs, computer systems, and also software engineering. Okay, and not to forget about the control theories and also system engineering. But there was many years ago, but as the technology advances so quickly nowadays and the complexity of systems continues to evolve, so the definition of mechatronics has actually been broadened to include more modern technologies such as cyber physical systems, Internet of Things, sustainable technologies, robotics, and also intelligent systems, and many more, you name it. Okay, so just to make it a little bit simpler for you, when we talk about mechatronic systems, you can think about automations, right? You can think about automations. So anything that is automated and it behave in a way that you want it to be, then we can call the systems mechatronic systems. All right. So when it comes to robotics, it's actually a subset of mechatronic systems, right? Mechatronic is more general, right? More general, and robotics is a subset of mechatronic system that usually resemble the mechanics and the motions of humans or living things. Okay, so robotics is more universal, right? Universal, it can perform a universal task, or in other words, it can be reprogrammable. Okay, so today you want to perform this task, you can program it, and then next day you want to perform another task, you can do it so quickly. So just show you a few different types of robot systems. So first of all is the humanoid robot. So this type of robot is basically resemble the mechanics or mechanisms of a human being. And as you can see from the picture here, some of the example of humanoid robots, right? And also we have a bio-inspired robots like the lizard, the spiders, or the dogs. All right. So in nature we have a lot of creatures or animals whereby the mechanism is highly efficient that most of the machine nowadays cannot reproduce. Okay, so this kind of robot, like for example the humanoid robot and also the bio-inspired robot, most of these are still under development, right? Under research, and the applications is not really that wide. So what we will be looking at most of the time is the industrial robots, right? The robotics arm that you can find in the manufacturing plants, like the one shown here in the picture, and also some of the mobile robots, like the Mars rovers, Curiosity, and the robots that you can find in the modern warehouses for logistic purpose. Okay, so in general, mechatronic systems is a system that is automated, right? It's automated and intelligent in a way that it behaves the way that we want them to behave. Okay, and robotics is basically a subset of mechatronic systems. So these are the sub areas of robotics and mechatronics engineering. So as I mentioned before, it is a combination of mechanical engineering. So in mechanical engineering, we will learn and apply statics and dynamics. We learn machine designs, right? How to design the mechanisms, and also we learn about 3D modeling, how to come up with a 3D model of a products, of machines, and then we also learn a little bit on materials, all right, on materials and their properties. And then also it includes the electronics engineering, which you will learn about circuits, electronics, semiconductors, digital electronics, microcontrollers, sensor actuators, and also signal processing or maybe image processing. Okay, and when it comes to software, there'll be quite a big part of programming involved, software developments, and also most importantly is the embedded systems programming. Okay, so basically you program you program the embedded systems to carry out some tasks. Okay, and then it also encompasses control engineering, where you will learn about the control theories, automations, and also the robotics controls. Okay, and I think it similar to all types of engineering fields, we will be involved in engineering designs. All right, but in more specific, we'll be designing robot systems or mechatronic systems or some other research projects and developments. All right, and it also involves engineering management, which is very important in all engineering fields. All right, so you might want to ask, what is the career path where you will be working, in which industry you will be working in? So here I give you some examples. Obviously, you can work as an engineer in manufacturing plant, right? Manufacturing plants that has automations. I think nowadays most of the plants are already automated, and then also industrial robotics. Of course, more and more industry is getting in robotics arm to help them to perform the routine job, right? Routine jobs, and maybe some smart system that involve drones, right? Or automotive industries. Nowadays, you can find tons of sensors and automation systems in the cars, and that is what a mechatronics engineer will be doing. Okay, and you may also work in logistics. So nowadays, robotics are used in most of the big warehouses to sort the packages or their products. Okay, and then in healthcare also, right? Nowadays, there are so many robotics arm or any machines that help you to help the doctors to perform some tasks. So healthcare, and most importantly, nowadays, because of this Internet of Things technologies, a lot of sectors are getting smarter, and a lot of digital technology is integrated, right? For example, smart energy systems, right? Smart energy systems, smart farming. So you will have a lot of sensors in the farm, and then probably you want to have some mechanisms to automate the harvesting process or any other task. Okay, and also smart cities. So in smart cities, something like smart industries, smart parking, smart homes, smart energies, and so on. So all these things, when it comes to sensors, when it has sensors involved, some automations involved, then that is where you will find mechatronic systems. All right. So I would say that just now, Dr. Victor has mentioned that the borders between different engineering field is getting blur. So a lot of industry out there is actually multidisciplinaries. Okay, so similar goes to robotics and mechatronics. You can essentially you can basically find everywhere right nowadays. So I think that's it from me, and the shortest presentations, right? It's already 5 o'clock. Thank you. Pass back to you, Nico.
All right, thank you, Dr. Lai. It was a very precise and interesting presentation. So now, if anyone has any questions, I'm sure all the guest speakers are in the room. Would be pleased to answer them as well. So yeah, any question, guys? You may type it in the chat box or like on your mic. Don't be shy. Any questions? Any questions, guys? No questions?
I guess you're all very shy today.
Yeah. No questions?
No questions.
You can ask anything. Anything would do. No worries.
Lai, I have to admit, I forgot R&M. You guys are the youngest among us. So yeah, not that young program anyway.
Yeah, we are kids.
You win. Okay. So basically, Kelly, Nicole, you guys are already our engineering students, right?
Yeah.
Yeah, perhaps you can help with this future possible engineers in the making who may enroll for engineering program. What do you think will be the questions that you wish somebody have asked before you actually join the program? You guys can ask too.
Coming back and asking me. Wow. Okay. Let me think.
It's better than silence here.
Yeah, I know. Right?
It would be like sitting until 5:30.
Okay. I would say like probably like most of the students will be like expecting like more of like physics and maths like when they take up engineering program. And like yeah, we are like unaware of like what engineering is really about, because like people will be like, oh, engineer, physics and maths, oh, that's it.
But
Yeah.
the reality, it's a lot more fun than physics and maths. I think high school undermines the whole thing. If it was just physics and maths, I've never have made it through engineering school. Okay, there's a question here by Eden. What can the what can students prepare for university life? Please do not call us Miss, Cikgu or teacher. That's a good start. At least here, most of us are quite open. Like I don't really ask students to call me doctor, no professors. Don't call me teacher. Something like that. Be a bit more open-minded. Be willing to ask. And I think one thing, nothing personal against, but I think Asians were very shy. So we have to drop that. Yeah, very shy. So you will want to be a bit more open, so that the more open you are, the more willing you approach people, the more you learn. And seniors are valuable asset. Yeah. Any other questions, anyone? No? Nada? Lai, ask you, are you still around, Lai?
Yes.
Yeah, what do you think you would have wanted somebody to tell you before you actually enrolled for your engineering course? Let's ask. Yeah, ask you one. Of course, you were also a student once.
Okay. I think the high school nowadays, the education system preparing students to pass exam, right? Rather than
correct.
So it's a mindset that has to change, right? You are not here to pass an exam and get a HD, get an A, but is to learn the knowledge, right, and the skills.
Correct. You have to forget about the grades. If you put too much emphasis on the grades, you lose out on the fun. What is
Yeah,
the most difficult thing about an engineer?
it's no longer a master, a sifu, and apprentice type of relationship, but it's a more like a collaborative or how to say discussions rather than I pass you the knowledge.
Correct. The more willing you are to open for conversation, the more you learn.
Yes.
So there's one from Chia Suk King. What is the most difficult thing as an engineer? So how many engineers we have practicing here? Let's ask Dr. Angela. Dr. Angela, what's the hardest thing as an engineer? I like this job.
She's still in.
Calling Dr. Angela? If not, Dr. Victor used to practice. Victor, what is the most difficult thing about being an engineer?
Suddenly it comes to me.
Yeah, of course not. I'm like looking at the name list. There's only a few of us who can be qualified as engineer. The rest are all in training. Can't ask them.
I think to me one of the things is not technical actually. It's mostly related to engineering ethics, like balancing what is right and what your bosses want. And the other thing is dealing with people. Yeah, that's why I said like you really need to learn how to work with people.
Yes.
Yeah.
You need to learn to work with different kind of people, because what a lot of people may well, at least what happened to me is my first presentation to my process colleagues were in perfect English. And then when I finished, everybody was just smiling at me. I'm like, why are they all smiling at me? It's awkward. That smile was so awkward. Then I was like, anybody faham? Then they were like, sit faham. I was like, oh. Yeah, so it's all about communication, working with people, and how to get things across and get something back, So that's the hardest.
Getting the message across. Sometimes it doesn't matter what language you use as long as people get it.
Correct. That's how I learn Bahasa. It's a learning
like
curve.
Students are like very shy. They do not dare to like really open up themselves to ask questions, and like, yeah, that's how a student like react to.
Okay, like students, for you guys already in university, right? This is like the perfect place to actually, forget about pride, man. My supervisor always tell me, swallow it, you never choke from it, So it's actually a very good training grounds to learn how to open up yourself. It is naturally, Asians were very shy. We are not that good at opening up, but you can practice it here because most of us are actually past that. I mean, I'm not this chatty when I was in university, but this is a very good training ground for you to actually learn to do this. Because once you leave the university, then you're already an adult, There's no more that benefit of learning how to open up and things like that. So try to join clubs, try to be a bit more active, Yeah. I don't know lah, but I like the idea that Lai brought up about the grade, because I've seen people I literally see their heart pop out with blood bleeding when they see that they don't get HD, It's not about HD here. I had a student that tell me first year it was nice, because if your fundamentals are strong in high school, you get HDs. Second year, you start to see scratches. Third year, you're just like, oh yeah, I managed to answer. Yeah, that's how universities are.
But I believe most of our students are actually aiming for HD.
That's why they feel the ouch when they arrive at second, third year.
You were calling me just now, is it, JJ? Sorry, I was in another meeting at the Zoom.
No worries.
The student text saying someone is calling my name, so I have to log in. Anything?
No, there was a question. What is the most difficult thing as an engineer?
Oh, okay. That's a very, very common question. I would say probably interaction with people. You get to
the same thing.
Different kind. You get different kind of people. I mean, and of course, being scolded by client, that is the most. That was the first thing that I faced when I was an engineer. You get scolded, because they are the prime master, so they can say anything they like. So you have to prepare to be thick fast. Scare the students, or I don't mean to discourage them, but it is a good experience actually. You will ended up become very thick skins, and everywhere you go, you feel that you are the best person in the world. Yeah, so probably interaction with people. You got to learn all those soft skills, you know. Your EQ got to be very high, not only IQ. So those are the things that you know, the most difficult things to learn, because if you are not born with it, then it will be very, very, very difficult for you to swallow all this. Yeah. Other than that, of course, you got to pass your, you know, before you become an engineer, you got to pass your degree. That's it.
How many of you will be having SPM this year? There's a question here. So how many in this room will be having?
Asking our student here.
Yeah.
No answer? You can raise your virtual hand. We can see you. If you are shy, just raise your virtual hand. We can call out your name.
No. Let's not call out the name. We'll just say we can count.
We can privately message you.
Yeah.
You can raise hand. You can raise hand.
Just raise your virtual hand. Yeah. I think I saw a few. Is it a few? Nicole, why are you raising your virtual hand?
SPM lah.
Oh yeah, I saw there's a batteries. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think most of you are in your SPM class, is it, Nicole? Are they all from their Form 5?
Yeah, Form 4, Form 5. Most of them are from Form 4, Form 5.
Oh, okay. Wow, good. We see many hands. Probably we can pick one or two, JJ. We
yes.
target to ask them questions. Let me see.
Wow, one or two. You may ask SPM question.
No,
That's a long
SPM
time
questions. Probably what is the next probably the path? I mean, after the SPM, what do they want to do, or what courses they are looking at? You know.
Okay.
How is online class? Who is asking these questions? Eden, is it? Have you attended any of the online class, Eden?
Is Eden our student?
Yes. Probably
Which
we have to check
program?
with, probably we have to check with Victor.
What is
How
his
was your
Yes.
online class,
He's our
Eden?
student.
Have you attended any of the online classes?
Correct. That's the question. Who's the lecturer here?
Me.
Apa macam he attend this class or not?
Yes, okay. All right. Yeah. No question from our SPM students?
Oh, very quiet, huh?
Deshaun, you're still raising your hand. Any question for us?
You can type it out if you don't want to. If you don't want us to hear your voice.
Yeah.
No. SPM this year, huh? They're having physical exams, right, this year?
I thought it's still ongoing, right? SPM, or is it done?
I think this is now is I think today last paper for the science
Is
stream.
it last paper? I thought it's spread throughout a few weeks.
Wait. There's one more bio paper, right? Coming. But they're very shy. Wait, nobody asking anything.
Maybe you can give bonus marks in the future for whoever asks a question.
Oh, I can only do that if they join my program. Wait.
Let me pick one. Is Nicholas around?
How's the job progression in? Okay, that's one. How's the job progression in engineering? Lao Ziyu, can you clarify when you mean by job progression is what do you mean? Like 5 years, 10 years?
Progress
opportunities? Yeah.
Yeah. Or maybe you can speak up. Okay, I think what he means is how long do you need to progressions? How can you progress from one level to another?
Is that true?
Is it what you mean, Ziyu? Okay, no response. This is what we usually get during online classes.
All right. Okay. There's a response. Well, not bad. This is a good student.
Oh, this girl is very ambitious to move up the corporate ladder. Like a normal. Okay. So, Jerry, you want to answer or I go? Let me see.
Okay. I go from my past experience. Engineers I did a manufacturing position, process engineer. So there's about 4 level in my past company for junior to senior, and then senior to managers is another 4 level. So typically people will take, if you're good, 1 level 1 year. So to manager about 10 years.
Okay,
Exceptional one, 6 years.
I do agree with JJ. If you're not in the manufacturing industry, if you are just working like a normal design engineer, basically after 10 or probably I would say after 8 to 10 years, you will be in the managerial level. Means you don't really need to be at the site to be the resident engineer or to be a site engineer, but most probably like what you mentioned, corporate ladder, you will be a manager. Of course, you are still an engineer, but you will be at the managerial positions. This is basically, of course, there are exceptional cases like what JJ said just now. If you are lucky or if you are extraordinary, probably you can become at this level within 5 years. But definitely, you have to go through very similar process like every one of us. You have to go through like 4 to 5 years of training before you can probably move another step higher. To you, may I know, are you interested in engineering or other profession?
Yeah. Probably
okay.
Okay. Engineers typically will divert into 2 areas. You either become a professional in the technical side or you move on towards administrative roles. So it depends.
Yes,
and then we say that it's about 6 to 8 years. But it all depends on individual because it's your internal motivation that drives you. We cannot tell you, okay, after 1 year, you definitely get a promotion. So it all depends on individual.
We don't promise that, yes. But then for engineering, there are opportunities like what we mentioned earlier in our talks. You can even venture into, becoming a consultant, then that's your own business. So you don't really need to climb up the corporate ladder. You are the leader. So you see, so that's the difference. If you take up engineering, this is something that you will really gain the experience and the opportunities. So you. And just now, where were we? I was calling for students' names.
You were calling for Nicholas, I think.
Yes. Okay, Nicholas. Nice meeting you. Are you interested in engineering or what kind of profession you are looking at? Well, something wrong with the mic, I think. I couldn't hear him.
Yep.
I don't think he's still muted.
Maybe he talked and forgot to unmute.
Yeah, he's muted.
Nicholas is online. He said yes. You want to ask him something?
You're online. So I asked already. So do you want to type your answer in the chat group or you want to speak to us? JJ, it seems that we are scaring them off.
You leave the room straight away.
And now going to Lai's course, Robotics and Mechatronics, because Lai seems to be very, very, very good. And then,
Lai is funny.
Hey, where is Lai? Lai locked out already, is it?
Lai is next door. I go knock his door.
Still here. Still here.
Hey, wait, where were we? Okay, no more questions from other students. So Nicholas, you're interested in engineering? What separates an average engineer from an excellent engineer? Wow.
A curious mind.
Wow. I would say things that motivate you, because that's actually separates an average engineer from an excellent engineer. You can even, you can actually live very comfortable if you are just an average engineer. You get paid every month, quite a very handsome amount. Yeah, like about 3-4. I would say that we go back to your questions. I would say your increment will be about 3 to 4, maybe let's say about 300% per year. So after 10 years, probably you will have about 6 to 7,000. I mean, as an average engineer, you'll be getting about 7,000 or 8,000 per month. So it's quite a handsome pay. So basically, becoming an average engineer, basically you can survive well. So if you were to become an excellent, you want to venture into business, or if you want to take up other role, then you got to be very, very, very motivated. And like what JJ said, you have to have a curious, you got to be hungry.
Correct. That's the thing that separates us.
You have to feel hungry every single day. Then you will move forward.
Yeah, you have to drive yourself to go up and up. Yeah. Because if you stay stagnant, you are going to have a very comfortable life. But if you want more, you have to drive it yourself. Nobody's going to force you. It's all about yourself.
Yes, I do have friends that actually being in as a consultant for more than 12, 13 years. So probably now he's already the associate, but he's just happy with what he's, he don't want to become a professional engineer. He just want to be an engineer without the licensure. So because he don't want to take, once you are a professional engineer in a consulting firm, you got to be responsible of your design. So he's just happy with in design. I don't want to sign. He leave it to the other people to sign. He's getting about 10K per month, and he's happy with that. So this is like a different desire in life.
Correct. So that's basically what separates the average and the excellent.
Yeah. It doesn't need to be okay. Probably there's another exceptional case. You don't need to be a top scorer in your.
That is true.
You got to be street smart. You to be very creative. So that are some of the attributes or criteria to be an excellent engineer. I mean, of course, top scorer will be an added. Is a bonus now.
It's a bonus.
It's an entry point. I mean, if like entry requirement, if you get a very good result, then probably your employer will actually look at that as a bonus. But soon after, it really depends on individual. Okay.
If I actually put it simply, right, it will be down to passion. That's all.
What is that,
really
Victor?
Passionate. No, it's all down to passion.
You got to love your job.
Yeah.
Correct.
If you really love it, you're passionate about it, you go very far.
Yes, because you see, like I remember I quoted the phrase from Confucius. He said, if you love your job, you basically don't need to work a single day, because you don't feel like working, because basically you're doing what you like. I don't know how to phrase it, but it's something from the Confucius. So you got to love your job. You got to be passionate. Then you will enjoy each day of your working life, because it's going to be with you for the next 30, 40 years.
Angela, I think you found a new fan.
Will
you be teaching me? I'm interested in civil engineering. Yes, she will be.
Oh yeah, okay. Oh yeah, who is? Okay, Nicholas. Okay. Yeah. Okay, good. Okay, I hope to see you in our civil engineering programs. Probably he don't want to come to Swinburne. Probably I'm interested in civil, but I'm not going to Swinburne. Okay. Good.
I will just roughly explain how to enter the quiz. First, you can use your own desktop or phone. Then you have to search Kahoot. Okay, or you can just use the link I sent in the chat box. Then next, you will be redirected to this web page. Then you have to enter the code, which is this one, 715 and 691. And make sure, please enter your own name and don't enter your nickname in case we cannot recognize the winner.
Yeah, so everyone use your full name, or like any names. I mean, like not nicknames.
Yeah, I saw some join. Nicole. Nicole.
Confirm Eden or Jack or anyone.
Okay, so before the game start, right, I will explain how this game works. So first, you will see the question on the screen. Then you will see 2 or 4 answers with different icons and color with different answers. So click the correct answer on your own device. here is a little tip for you guys. The faster you click the correct answer, more points will be rewarded. And for better gain experience, I personally suggest you to use the on form. Yeah, so you can be faster to click the correct answer. I think I will start in 3 minutes.
All right, thank you, Dr. Victor.
Thanks, everyone.
Mercy.
Enjoy the quiz session.
Thank you, Dr. Victor. Oh, Eden.
A suggestion: someone can join with the name Eden Sherwin or something.
Nicole, you can use either name.
I know, right?
Yeah. So we'll start in 1 minute. Okay, we'll start again now. Okay.
Okay. General quiz. Let's do this, guys. 10 questions.
Okay. Wow. Okay.
I say majority
Wow, okay.
gets it.
Yes. Oh, yeah. For information, you have 20 seconds to read the question and answer.
Okay.
Okay, next.
Mm-hmm.
Mika.
It's not me. It's not me. It's not me. I have to clarify myself now.
You want the Grab voucher, is it? Not bad. Okay, next.
Nice.
Nicole, you still the winner.
Whoa! Whoever use this name, you jaga.
Wow, surprisingly. Chloe Bong.
Chloe.
Yeah. Okay. Keep it up, guys.
Fun one.
Yeah. Nicole. Good. Okay, next.
Yeah, very good. What you guys?
Yeah, Nicole don't even know the answer about this. Yeah.
True or false?
Yeah. Fast. Ta-da.
Oh, I think Chloe scores everything.
Yeah, and Brian, I think. Nicholas.
Who is this Nicholas? Oh, I wonder.
Okay, last question. Last question. Oops. Okay. So everyone thought that tomato actually is vegetable. Okay, let's see. 7 out of 10. Congrats to Catherine.
Why say? Genuinely. Chloe.
Oh yeah.
Congratulations, guys.
I
Fourth Cheryl, fifth Jane. Yeah, can we see the name, right? Yeah, can we get the name?
Oh,
For
where?
the first 10 winners.
Can.
Yeah.
I find the full report. Where?
Hi guys, there's no lecturers inside here anymore. So do you guys have any question to us or like anything? Yes, no. So don't be shy, huh?
Okay, yeah. So the first 10 winners over here, and we will email you the prize. Yeah.
By this week, huh?
Yeah, by this week.
Okay, cool. So guys, do check out your email that you guys have submitted through the Google form previously. I hope you all registered yourself, huh? So yeah.
Wait, let me send the Google form link. Sorry. Forgot key.
No worries, no worries. Thank you, Eden.
Eden send already. Okay.
Just it.